This week we're going to do something a little different than we've done the previous 3 weeks. We're switching from a deterministic world where everything is known and we can optimize to an uncertain world where things are probabilistic or stochastic, where there's a lot of uncertainty. And so what we're going to do in this week is kind of give you an idea of how to manage and characterize uncertainty. We'll start with some basic probability, get into how to characterize outcomes, and then we'll finish up with some distributions. So these are just basic tools for you to capture, characterize, and manage the uncertainty you'll see every day. And so to illustrate this, I'm going to run a little experiment. So every day in the supply chains, you are running experiments. For example, how many orders get called in? That's a random number because it's not known with certainty. So there's some distribution that it probably falls. So every day you have all these random experiments. And what we're going to do right now is I have 2 coins, and I'm going to shake them up and count the number of heads each time. And so what I'm going to do here is build what's known as a histogram. And a histogram is simply a graphical representation of a series of outcomes. And I can do this many, many times, and the more often I do it, I will get certain outcomes. But let me just stop there, because it's nice. It actually worked out quite well. And I really did report the number of coins that came up. But I want you to look at something, what we did. So we did a random experiment in that I shook and had number of heads. And so I can say my random variable is the number of heads that show up on the 2 coins that I tossed. And looking at it and thinking about it for a second, there's only 3 possible outcomes, right? I could only have 3 possible outcomes. I could have 0 heads show up, I could have 1 head show up, or I could have 2. And so what we've done is we've just defined the sample space, so the total population of the values that it can be. Corresponding to each of these values, I know that there's a probability that it occurs. And in this case, it's 1/4, 1/2, and 1/4. So looking at this, I can notice a couple other things. One is I see that the sum of all those probabilities, if I'm mutually exclusive and collectively exhaustive, sums up to 1. So all my probabilities have to sum up to 1. Also, we see that I have a sample space and I have probabilities corresponding with each potential outcome. So just like this is a simple experiment, in real life, you've got things like this as well. So let's say I'm looking at the number of bagels sold in a coffee shop each week. And here's my frequency. And let me just put some numbers here. And some weeks I sell 0, some weeks I sell 1, some weeks I sell 2, 3, and so forth. And I could capture this in a histogram again of the actual data. And what I've done here is what's known as an empirical distribution. So an empirical distribution is just simply a distribution that reflects the underlying data. I just captured what happened. So one of the questions we have here is, how do I characterize that? And so if I have this distribution, there's 2 main ways. There are many ways, but there are 2 ways that we're going to focus in. The first is what's known as central tendency. And what this means is we want to find what value is most likely. So we can think of different ways to do this. One would be the mode, which is the most frequent one that showed up. Maybe I want the median, which divides the distribution in half, 50%, 50%. Or maybe I want to find what's known as the mean. And that's where I would be able to, if I wanted to put a fulcrum under here where it would balance that distribution. We also call that the average. But there are different metrics we can use to capture central tendency. The other way we can characterize this is by looking at the dispersion. Sometimes this is also called the spread. And so what we're looking at here is how distributed, how far away is it from that central tendency or the mean. So we have different ways of measuring this dispersion and spread. Well, I can look at the range that it covers, so the max minus the min. I can look at breaking this into quartiles, or I can do something called the standard deviation or the variance that looks at the expected value of the squared around the mean. And we'll talk more about this. But essentially, I've got different ways that I can characterize and capture the essence of an empirical distribution. The last thing that we'll cover this week is we'll look at sets of theoretical distributions, because while this is interesting, at some point we want to capture and say, what does this look like? Does this look like some sort of theoretical distribution because we can do much more with a theoretical distribution. It has different properties. So we're going to look at 5. We're going to look at 2 discrete distributions and 3 continuous ones. The first discrete one we're going to look at is known as the uniform, discrete uniform distribution. We're saying this means that the data, the outcomes are distributed uniformly between the values A and B. And so you can think of this as rolling a dice, 1, 2, 3, 4, 5, 6, where A is the minimum and B is the maximum, and they're all equally likely. The next one we'll look at is called the Poisson. And this distribution has one parameter that describes it, lambda, which is the mean, and it allows me to capture the arrivals, or the number of arrivals that happen over a certain time period. We'll find this very useful when we look at certain inventory problems. So these are 2 discrete distributions. We'll also look at some continuous distributions. We'll look at a uniform continuous distribution. And what this looks like, it has the same parameters, a minimum and a maximum, but then the outcome can be anything in between those, not just the discrete values. We'll also look at one of my favorite distributions, the triangle distribution. And I like this because it's really good at estimating. And it has 3 parameters, a min, a max, and what's known as a mode. So it's going to look something like this, and you'll see why it's called a triangle distribution in just a second. It looks something like this. And we'll go into details of why to use this and how to use this. And we'll finish up with the granddaddy distribution that everyone knows, the normal distribution, because it's widely used. It's also called the Gaussian distribution, and it's that bell-shaped curve that we all know so well. And it's distributed, or its parameters rather, are the mean and the standard deviation, where the mean is this value and the standard deviation is the spread. So we're going to cover a lot of ground here, but it's really all about capturing and managing and characterizing uncertainty. This is the uncertainty that happens every day. Variability in demand, variability in delivery times, variability in supply. How do I capture that? So watch the videos, take the recitations, use the quick questions and the practice problems. The best way to learn this stuff is to practice, practice, practice so that you get a really good handling of all 5 of these distributions. All right, have fun.